Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on evaluating reverse Polish notation. Let me explain what is the Polish notation and how we are going to solve this problem. Okay, so let's jump into the problem statement, understand it and start solving. So last time we have solved the clone graph problem. You can find it in the list. Let's start with reverse Polish notation. Okay, let's go through the problem statement quickly. You are given an array of strings tokens that represent an arithmetic expression in a reverse Polish notation. Evaluate the expression. Return an integer that represents the value of the expression. Note that the valid operators are plus, minus, into and divide. Each operand may be an integer or another expression. The division between two integers always truncates towards 0. There will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all intermediate calculations can be represented in a 32-bit integer. Okay. I know it would be little difficult to understand the problem like this. So let's understand it from the examples. So you can see we are given the tokens like 2, 1, plus, 3, into. And the output is 9. This is what we have to return, and the explanation is 2 plus 1 into 3. Okay, let's understand how reverse Polish notation works. Okay, so reverse Polish notation, let's write let's take the next example. Okay, let's take this example. So let's say we are given this tokens. So what we are going to do is we have to check the first operator. Okay, let's check the first operator. Divide. We found divide, right? So we have to do divide of the last two numbers that are available. Okay, so this is a divide and the last two numbers were 5 and 13. So we will do first operation would be, so answer will look like 13 divided by 5, and let's put it inside one bracket. Okay, now this is removed from here and 4 is left with a plus operator. So now 4 will come on the left side, 4, and then plus operator will come here. But how did we arrive here? Let's go back a step. Okay, once this problem statement is solved, this variable we can now represent it as let's say the solution of this. Okay, what should be the solution of 13 divided by 5? 2 in this case. So we'll say 2. Okay, now we'll search for the next operator. Next operator is plus. So what will happen? First operator plus second operator. So first operator would be 4 and then plus, and 13 divided by 5 was 2 equal to 6. Okay, I hope that was clear, but let's understand this bigger example as well, just to make it very clear. Okay, so we'll take it here. Let's remove this part. Let's take, this is the available token. Okay, so simply so this is actually post let me also show you the definition for reverse Polish notation. If we go on Wikipedia, this is postfix notation. So 3 plus 4 and plus operator, that means 3 plus 4. If we understand it from a simpler example, we can say, for example, to add 3 and 4 together, the expression is 3 4 plus. Okay, in Polish, in reverse Polish notation, which means 3 plus 4. If you see 3 4 minus 5 plus, that means first we search for the first operator, that is minus. So we do 3 minus 4 and then we search for the plus, that is overall plus 5. Okay, let's go back to the example. So we have this example. Okay, we'll search for the first operator. First operator is this plus, and last two operands were 9 and 3, right? We'll do simply 9 plus 3, right? And let's remove them from the notation. Okay, next we see the next operator, that is into. we are seeing a multiplication. Okay, 9 plus 3 have already been calculated, that's why I removed them. You can see 9 plus 3 were here in the operation. Okay, now we see a multiplication sign, and what, 1 second, we have to keep them constant. So 9 plus 3 have been resolved, and the plus sign is gone as well. Okay, we have used them here. Now we see minus 11, and the next operator is multiplied by. So we have to multiply 11, and the second operator would be the answer of this operation, right? 9 plus 3. So we can say this, we can take it in bracket, 9 plus 3, and then into minus 11. Now this complete expression is solved for us. Okay, next operator is divided by. Now how will we divide? We will divide first operand divided by second operand. First operand is 6, second operand would be solution of this expression. So let's take this complete expression into bracket. Okay, and this complete operation has to be divided, 6 divided by this. So now 6 divided, this is complete, right? Our next operator is multiplication. So what we will do, we'll find out the earlier two operands. Operands are numbers, operator is these operator, plus, minus and all. So first operand is 10, second operand is the solution of this one, and then we have multiplication. So we'll multiply 10 into this expression. So we will say, we'll take this into one bracket, and we'll say 10 into. So this complete up till here has been resolved, right? Now we see 17 and we see plus operator. Next operator has come up plus, so we'll find out the earlier two operands. Earlier two operands are this expression and 17. So this expression is first operand, so this complete operation would be first operand, right? So we'll take completely into one bracket. Let's start from this side. Okay, and then plus operator and 17. So up until here we are done. Then we see the next operator is plus again. So we do first operand plus second operand. First operand is this expression which is written here, plus 5. So we'll take another, we'll take it inside bracket, and we do plus 5. If you see, this is the solution expression, and then simply when you solve it, you'll reach the solution as 22, because 12 plus 9 plus 3 would be 12. 12 into minus 11 will get 132. 6 divided by minus 132 would be 0. 10 into 0 would be 0. Plus 17 plus 5 would be 22. Okay. Now the key thing to notice here is that every time we are searching for operators, and whenever the given thing is that a valid expression exists. So always we have a valid expression. So each time we see a operator, we find out the last two operands. Okay, we take the last two operands and perform this operation. So what we can do is we can actually put the use a stack. Okay, so let's say I'm using a stack. What I will do is one by one I'll add the number to the stack. Okay, let's take example of this one. So I see 2, I add it to the stack. I see 1, I add it to the stack. So this is the back, this is the lower side, or let me make it like this. I got 2, I added here. I got 1, I added 1 on top. Okay. Then I saw operator plus. Whenever I see an operator, I pull out the last two elements, 1 and 2 will be in this case, and perform this operation. So last one would be 2, and then plus and 1. Okay, and that is equal to 3, and then I will insert 3 back into the stack. So 3 will be in the stack. Next I see another 3, I'll insert that as well in the stack. Next I see multiplication. whenever we see operator, we pull out the last two operands, 3 and 3. So solution will become 3 into 3 equals 9, right? So we'll use the stack to save the operands, and whenever we see an operator, we'll perform the operation. So we'll use stack, we'll create an operation method, and we'll figure out whether there is an operator or the operand. So with this, let's start solving. Okay, and that should make this very clear for everyone. Okay, so we'll create a stack to keep track of operands. We can say stack integer stack is equal to new stack. Okay, now we'll iterate through the tokens, this given string of tokens. Okay, we'll say iterate through the tokens for string token from tokens. If so, first we want to check whether it's a operand or operator, right? So let's create a method for if this is an operator or not. Okay, this public method, let's create another. We'll call it a helper method to check if the token is an operator. So simply we can check it, private boolean is operator. We'll pass the operator string token. We'll check return token dot equals. So if it equals to plus sign, that means it's operator, or if token dot equals minus sign, it's operator, or if token dot equals multiplication, it's operator, lastly, or token dot equals divided by, it's operator, right? Let me shorten this window. Yeah, it's operator. So simply, if any of them is relates, if it's either plus, minus, multiply by, or divide, will return true, otherwise will return false. So we'll call this method if is operator, and we'll pass the token. If so if it is a operator, that means we have to perform the operation, right? Let's write the else part first. Else, if it is not operator, that means it's an operand, that means it's an integer. So if the token is an operand, convert it into integer and save, right? Because they are given in form of strings. So we'll push to stack. So we'll say stack dot push integer dot parseInt, and we'll pass the token. But if it's an operator, that means we have to perform the operation. So we can simply say if the token is an operator, pop two operands from the stack and perform the operation. Okay, now we'll pop the elements like this. Int operand, will pop the second operand first, right? Because in the stack 2 is going first, 1 is going later, and it will be easier for calculations where we have bigger expression. So operand 2 is equal to stack dot pop int operand 1 is equal to stack dot pop. We don't have to check if there are elements in the stack or not, since the expression is always valid. Int result is equal to now every time we have to perform this operation, right? So let's create one class for one method for operations as well. Let's create one. So we'll call it helper method to perform operation based on the operator, because we can have plus, minus, multiply, dot, divide. So we'll call it private int perform operation. We'll pass the two operands, that is int operand 1, int operand 2, and string operator. We'll say we'll use switch method. We can simply use the switch, switch switch operator, right? We'll say case. I'm sure everyone is aware of the switch methods. If not, please check online. Return. So if it's a plus operator, we'll return operand 1 plus operand 2. Done, right? Similarly, we'll, let me just copy paste for easier. Like paste. So similarly for minus, operand 1 minus operand 2, right? For multiplication, operand 1 multiplied by operand 2. For division, operand 1 divided by operand 2, right? And let's keep one default case also, though that is not necessary in this case, but as a good practice, default throw new illegal argument exception. If you are not aware of the how to throw exceptions, please ignore. You can ignore this line of code, but it's just as a good practice. Invalid operator, that is to say that the provided operator is invalid operator. Okay, that's it. That is all that will take place in this method. Okay, this method is just to perform plus, minus, multiplication and division between the two operands that we have. So now each time we want to find out the result, we can simply call the method. We'll say perform operation and we'll pass operand 1, operand 2, and our operator, which is token, right? Because when it is a token, only then we are performing this. Once we have figured out what is the solution, as discussed earlier, we'll push it back to the stack, right? So once we find out the solution, we can say push the result back to the stack. So this stack dot push result. That's it, right? Now we have done the for loop. We went through all the tokens. Everything is done. So final result will be in the stack, which will be on the top of the stack, since every time we are inserting the result back to the top. So we can simply say return stack dot pop. Since it's already in integer format, we do not have to convert. Let's run and check. Okay. Oh, where did we commit this mistake? Oh, I don't know. How did I end up writing a K here? Okay. Let's see. Okay, we do have some typos. Equals is equals. Equals, is there anything else? I hope not. Let's try again. Okay, let's submit. Okay, beats 78.49. I was hoping this would be a much better time complexity. I'll submit it again just in case. So let's check. 78. Okay, that's good enough. If anyone has a better solution, please let me know in the comment section. Yeah, the solution is actually really easy once you understand it. So I would suggest, if you are finding it difficult, please go through the video again, and please be aware that we have already reached the medium level in our grind 75 coding list. So all the upcoming problem statements and the solutions would now be a little difficult than our earlier easy versions. And sooner we'll be reaching the hard as well, and be prepared for that. Okay. That's all from today's video, and yes, I think everyone can be sure that the time complexity of this algorithm is O of n, since we are targeting each token only once, right? That's all from today's video, everyone. Thank you. For anything, please let me know in the comment section. So please like, share and subscribe. Thank you.